Look up at the sun, carefully, never directly, and you are looking at a corpse in waiting. It does not feel that way. It rises, it sets. It has done so for every single day of every life that has ever existed. It seems like the one thing that could never end. It will. The sun is a star, and stars die. Ours is already middle-aged, and the manner of its death is written. In physics, we understand well. A death that will boil the oceans, swallow the inner planets, and quite possibly take the Earth down with it. Our sun was born about 4.5 billion years ago, out of a collapsing cloud of gas and dust. Today it is an ordinary star, a sphere of plasma so vast that more than 1 million Earths would fit inside it, and every second, deep in its core, it converts around 600 million tons of hydrogen into helium through nuclear fusion. The warmth on your face right now began there. Though the light took just 8 minutes to cross space to reach you, the energy itself spent tens of thousands of years clawing its way out of the core first. That fusion is a war. Gravity is forever trying to crush the sun inward. The outward pressure of fusion pushes back. For now, the two are locked in near-perfect balance, a standoff astronomers call hydrostatic equilibrium. It is the reason the sun is stable. It is the reason you are alive. But it is a war the sun is slowly, inevitably losing. It holds enough hydrogen fuel for roughly 10 billion years of stable life, and we are a little under halfway through. The real trouble, though, begins long before the fuel ever runs out, because the sun is not the same star it was when it was born. It has been growing slowly, relentlessly brighter for its entire life. Today it is around 30% brighter than at its birth, and it is still brightening. The reason is subtle. As helium ash accumulates in the core slowly contracts and heats, and fusion burns a little faster each passing age. Curiously, this creates a puzzle about our own past. The newborn sun was so faint that the early Earth should have frozen solid. Yet we find evidence of liquid water billions of years ago. Astronomers call it the faint young sun paradox, and it is still argued over today. But it is the future that is lethal. The consequences arrive not in billions of years, but in roughly one. In about 1 billion years, the sun will burn bright enough to push the Earth past a tipping point. The oceans will begin to evaporate in earnest. Water vapor, itself a powerful greenhouse gas, will trap still more heat in a runaway feedback that feeds on itself. The seas will boil away into space. Complex life will vanish first. The last living things on Earth will most likely be hardy microbes, clinging to the final shrinking pockets of moisture. Before they too are gone. Long before our star becomes a monster, the Earth will already be a sterile, scorched rock, killed not by the sun's death, but simply by its middle age. Now fast forward. Around 5 billion years from now, the core finally runs dry. The hydrogen at the center is spent, and fusion there sputters and dies. With nothing left to push back, gravity wins its first great victory. The inert helium core begins to collapse under its own weight, and as it collapses, it heats. That rising heat ignites a shell of hydrogen still surrounding the dead core. And here comes the strange, almost paradoxical turn. As the core shrinks, the outer layers of the sun do the opposite. They balloon outward. The surface expands and cools, its color sliding from brilliant white toward a deep, sullen red. The sun is abandoning the steady star it has been for 10 billion years. It is becoming something vastly larger, stranger, and far more dangerous to whatever planets remain. It is becoming a red giant, and the inner solar system is now in its path. As a red giant, the sun will be monstrous, swelling to perhaps 200 to 250 times its present size, its glowing surface reaching out past where Earth now orbits. Mercury and Venus are simply doomed, engulfed and vaporized without a contest. Earth's fate is closer, and it has been genuinely debated. As the sun swells, it also sheds mass, and as it loses mass, its gravitational grip loosens. So Earth's orbit should drift outward, a possible escape route. But the most careful studies, like the 2008 work of astronomers Schroeder and Conan Smith, Find that escape falls just short. The bloated sun raises an enormous tidal bulge on the retreating Earth, and that bulge drags our planet back inward faster than it can flee. Their conclusion is bleak. The Earth is most likely engulfed, spiraling down into the sun's outer layers, slowed by friction and finally vaporized. The world that produced every human being who has ever lived, erased without a trace. And as the inner planets burn, something gentler and stranger stirs in the cold far away. The swollen sun warms the outer solar system. For a brief window, the frozen moons of Jupiter and Saturn may thaw, Europa's buried ocean surfacing beneath a vast red sun. A fleeting, improbable springtime in the outer dark. 10 times too late for us. Still, the sun is not finished. Inside that swollen giant, the helium core keeps contracting and heating until it reaches a staggering 100 million degrees, finally hot enough to fuse helium itself into carbon and oxygen. In a star like ours, that ignition arrives suddenly in a violent runaway called the Helium Flash. For seconds to minutes, the core pours out energy at a rate that rivals an entire galaxy of stars, though it is buried so deep that the surface scarcely flinches. Then the sun steadies once more, now quietly burning helium at its heart, a brief second act that may last 100 million years. But helium is a far poorer fuel than hydrogen, and there is far less of it. By cosmic standards, this reprieve is fleeting, and when the helium runs out, there will be no third act. The heaviest elements our sun can ever forge are carbon and oxygen. It will never burn hot enough to fuse them. The true end begins. What comes next is, improbably, one of the most beautiful sights in the universe. The sun, now unstable, begins to pulse, shrugging off its outer layers in great expanding shells of gas. Over tens of thousands of years, it gently casts away nearly half its entire mass into space. Lit from within by the searing core left behind, those shells glow in luminous rings and bubbles of color, a planetary nebula. The name is a beautiful mistake. Early astronomers, peering through small telescopes, thought these round glowing clouds resembled planets. They have nothing to do with planets at all. We see hundreds of them strewn across our galaxy. The Ring Nebula, the Helix Nebula, and every single one is the corpse of a star, much like our sun. Each is a postcard from our own future. The gas that was once our sun will drift ever outward, seeding the galaxy with the carbon and oxygen forged in its dying heart. The very atoms from which new stars, new worlds, perhaps new life, may one day be built. And at the center of that fading nebula, one thing remains: the sun's naked, exposed core. Roughly the size of the Earth, yet holding half the mass of the sun, it is so impossibly dense that a single teaspoonful of it would weigh as much as a truck. This is a white dwarf, the true corpse of our star. No fusion burns within it any longer. It shines only with leftover heat, blazing white hot at first. And then it does the single thing it has left to do. It cools, slowly, across spans of time that dwarf everything that came before. The white dwarf bleeds its warmth away into the dark, fading from white to yellow, to red, and at last to a cold black cinder. That final stage even has a name, a black dwarf. But here is the remarkable part. This cooling takes so unimaginably long, perhaps 1,000 trillion years, that in the entire 13.8 billion year history of the universe, not one black dwarf has had the time to form. The cosmos is simply too young. When our sun finally goes dark, it will be among the very first. Every white dwarf in the night sky tonight is a glimpse of that future. Billions of them already scattered through the galaxy. The cooling hearts of stars that died before ours was even born. So this is how our star ends. Not in a sudden blast, but in a slow, certain unwinding that was written into its very first day. It will brighten until it sterilizes us, swell until it swallows us, and fade until it is nothing but a dark ember adrift in an empty sky. 5 billion years is an almost unimaginable gulf of time. Humanity, if it endures at all, will be unrecognizable, long gone or scattered out among other younger stars. But the sun keeps its own schedule, indifferent to us. The light that made us will, in the very end, be the light that unmakes us. And the clock is already running.